Good afternoon, everybody. Welcome to our Geo Drone Solutions and SPH Engineering webinar. It's terrific to have you here. Our webinar is called Unleashing the Potential of Drone-Based Bathymetry, and we'll certainly do our best to make it as interesting as possible for you. Yeah, again, welcome. We really do appreciate your time and appreciate that you're very busy. So it's terrific to have you here. My name is Mark Hickley. I'm the Director and General Manager of GeoQ Australia and Geo Drone Solutions, and I'll lead us through the webinar today. Joining us from SPH Engineering is Alexei Smirnov, so thank you for being with us, Alexei. Alexei is the Regional Director for SPH Engineering, and also with us is Daniel Wood. Daniel is our partner and customer from Working Drones down in Canberra. So thank you very much for being with us, gents. And I'd also like to thank SPH Engineering for their partnering and helping us to organise the webinar, and you know, at this stage it looks like we've got great attendance and interest, so that's great to see. So today we'll be covering the SPH Engineering drone Bathy system. Obviously, that's central to what we're talking about. I'll explain GeoQ Australia and Geo Drone Solutions and how that all fits in, and introduce our staff. We'll talk about our general bathymetry options and other related products and systems, and we'll talk about, you know, the specific benefits and reasons for using and employing the SPH Engineering drone Bathy system. And lastly, Daniel will talk a little bit about his experiences with the system and how he uses it, and show us through a few different cases. So that'll be interesting. We'll do a Q&A session and a wrap up at the end, so certainly feel free to register your questions throughout, and we'll address those at the end. So just in regard to the format, Alexei will speak first, and then myself, and Daniel will bring up the rear, and at the end we'll do a Q&A. So I will hand over to Alexei. Thank you very much, Alexei. Welcome.
Thank you, Mark. Thank you for this introduction, and it's really a pleasure to be here, and it's a really honor. Yeah, as Mark said, I'll do a brief overview of what is drones can give us in terms of bathymetry projects, how it can help, why should you use drones, when should you use drones, what is the possible applications, and what are the possible options to use drones in your bathymetry projects. And I would start with a short definition of what the bathymetry is. I'm sure the majority of you know what is a bathymetry, but just to be on the same page. Bathymetry comes from around 3,000 years ago from ancient Egypt, and in Greek language it means combination of two words: bathos, which means deep, and metron, which means measure. And to put it simple, that's kind of topography, but for underwater. So you can study underwater depth of ocean floors, lake floors, river floors, just to get understanding what is hidden beneath the surface. And in the end, to get beautiful pictures like this, when you understand what is the depth of the lake or the sea or the shore you're measuring, what is the profile of the bottom, and even what is the sediment depth, sediment thickness. And these measurements are really important in many applications, in many industries. And in environmental research, when you need to understand what is the amount of water in this or that reservoir. And of course, in many commercial industries, for instance, in mining, there are a lot of reservoirs, starting with all these sediment ponds, tailing ponds, tailing storage facilities. And for all these ponds and lakes, you need to understand what is the volume of water, what is the water balance, what is the capacity of these ponds, just to avoid any possible leakage, any possible flooding, just to avoid all these unnecessary risks. Of course, you should control the stability of slopes during open pit mines reclamation, because sometimes water can reduce the stability of these slopes. You can plan, you need these bathymetry measurements for planning your cleaning activities, to determine water, volume of water for dewatering and all these things. And in the construction industry, of course, you need to know exactly what is the water depth and what is the bottom profile, because before doing any engineering works like building bridges or pipeline crossings, you do need this information to control your dredging works and to monitor these dredging works, because otherwise you don't understand how much dredging should you do and what is the amount of work you should do, all these things. And usually all these bathymetric measurements were being done in two ways. First way is old, good, and still working. Then you take a couple of guys, give them stick poles, give them canoe or kayak, and send them to the pond, and they spend the whole day measuring this pond's depth using this stick pole. And yeah, it works, but it's too costly, too time consuming, effort consuming. So less and less, fewer and fewer people and fewer companies are using this method. And the second method is to use boat equipped with echo sounder or some other sensor to do all these measurements. And these boat-based measurements are working good, but there are cases when you can't just use boat. And this is the cases where drones come in handy. What are these? These all things where you can't just use boats because of, for instance, hazardous conditions. For example, in the mining industry, some tailing storage facilities can contain not water, but for instance, acid. And I would not go and I would not send people on the boat in the acid lake. Or sometimes you can just access the terrain you need to measure. For instance, because of cliffs, because of trees, any type of obstacles. If the lake or pond is full of seaweed or debris, also boat is not always an option. And strong waves for boats, sometimes it's difficult to overcome them. There are several options, several sensors which can be used for drone-based bathymetry. First of them is green wave LiDAR. The idea is pretty simple. That's the same LiDAR as I believe most of you have already used, but it is different wavelength. And this wavelength allows to penetrate water. It works really well in shallow water, and it doesn't have any dead zones compared to other sensors. And the very idea to have all measurements like above the ground and below the water in one flight is pretty compelling and pretty prominent. But there are some limitations for this sensor, and the first of them is turbidity of the water. Laser can work only if you're measuring some clear water, and if your river or lake is turbid, that will hugely influence the accuracy. And the second thing, these sensors are still expensive, quite expensive, so not every company can afford using it. Second option for drone-based bathymetry is ground penetrating radar. That's a geophysical sensor which sends short electromagnetic signals below the surface, below the ground or below the water, and catch back the reflections, understand their refractions, and based on that, understand what is hidden below the surface. That's, to be honest, that's the only option if you want to do bathymetry for frozen or covered with ice lakes or ponds. And it can work, this sensor can work in strong currents because it have not, it didn't have to be, it doesn't have to be submerged. But as it is electromagnetic sensor, the penetration ratio is quite shallow, I would say, and it works up just to 15 meters. And it works only in fresh water with low conductivity, because that's electromagnetic waves, and all this conductivity matters for them. And the last option, and the main option we'll be talking about today, is the echo sounder. That's the same sounder, for instance, submarines use or dolphins use for their navigation. It sends sound signal, gets the reflections back, measure the difference in them, and based on that, calculate what is the distance from sensor to the bottom. It can measure really deep lakes or seas or rivers up to 200 meters. And if you use dual frequency echo sounder, you can even measure sediment depth, which is important, of course, for dredging, for instance. But there are also some limitations. These sensors have dead zone. Usually that's around 30 to 50 centimeters. So if you have to measure to do bathymetric surveying for really shallow reservoirs, then probably GPR would be the better option. And it doesn't work in storm current because, as you can see, sensor is mounted on the rope, and all these currents will influence the accuracy, and inevitably. And to get the most precise data, the most accurate data, you should use low flying speed, like about 70 to 80 centimeters per second. So it will take time to do big surveying projects, but it's worth it. And yeah, one of the most popular questions we have, like, okay, drones, ropes, sensors, all these things are moving, all these things are swaying here and there. Is it reliable and accurate at all? The short answer is yes, that's really accurate, and we had a lot of tests, and our customers have done a lot of tests. And here you can see picture where we compared echo sounder measurements with measure poles, and you can see that difference here is like 1 centimeter or a couple of centimeters. So that's this accuracy is enough for the majority. I mean, for all projects you can do in the bathymetry, so you can rely on these measurements like in any projects you have. And there are, of course, certain tips and tricks you can use to increase your data accuracy. Don't forget to do check lines. Check lines, that's when you finish your flight and do all this area scanning, you should do one line across all your surveying lines, that just to check if your measurements are repeatable. The second thing is to use the recommended flight speed. As I said, that's about 70 to 80 centimeters per second, or 0.7 meters per second. And of course, you can increase this speed if you need just estimations. But all in all, it's better to spend more time measuring, but not to return again to do rechecks, remeasurements, and waste even more time. And the next thing is you can filter out incorrect measurements if you have any in Hydromagic. That's a software to use for bathymetry data processing. And it's pretty simple. You'll see which measurements are incorrect, and you just can click on them and it will be removed. And of course, you can use corrections for tides, sound velocity in water, and any others. But I would even add that all these sensors, and for marine projects, that's you can do not only bathymetry. And if you have a big construction project, for instance, or big mining project or an environmental, there are some other sensors that can come in handy. First of them is magnetometer. Quite often, the place we need to build something or the place we need to, to survey something, contains something what is hidden below the water. It can be debris, it can be shipwrecks, it can be some infrastructure like pipes or cables. And to be sure that these obstacles, these objects won't stop us from doing our project, we can use magnetometry to understand all this and to find all these magnetic objects hidden below the surface of the water, and to create this beautiful magnetic heat map, which shows you where are the objects located and where you should be cautious and to avoid any obstacles. The next sensor is water sampler. That's pretty simple sensor which allows you to get to collect water samples, and you can use these samples to perform analysis of water contamination, of turbidity, and any other analysis of the water you need to do for your, for instance, environmental projects in situ. Just you send the drone, it grabs the water sample, bring it back to you, you send it to the lab, do analysis, and you understand what you have. And this samples collection is fully automated, so it really works for these projects when you need to understand what water do you have and what is the quality of this water. And the last but not least is our newest sensor, that's so-called surface velocity profiler. The idea of the sensor is quite straightforward: to measure the current velocity, and this is really important if you do any projects related to flooding prevention or flooding forecasting, because using this sensor you can estimate river discharge to understand how much water goes through the river or through the creek for a certain period of time, and combining this data with bathymetry data, you can predict, you can analyze risks, you can assess these risks, and you can predict possible floodings. These sensors should be available pretty soon. We are expecting to get field trials and field tests in September. And of course, we'll share all this information with all of you, just for you to know what this sensor can give for your projects. And to sum up all this, I would like to say that all these sensors are essential for simplifying your bathymetric and surveying projects, because it can it can help you to achieve way faster exploration speed and to minimize mobilization time, data acquisition, and data processing time. And as all these operations are done automatically in automated mode, you'll always get consistent and accurate data. So you'll get your insights on the mining site or construction site faster, and you can do all these projects in terrains inaccessible for classic techniques, and avoid unnecessary risk to personnel. And as we use industry-based standards and industry specific data formats, you can seamlessly integrate all this data into your workflow, and that will also help you to save your time, your money, your efforts for your next project. And now my colleagues Mark and Daniel will dive deep into details on how they use this bathymetry system in their projects, what is the workflow, what are the life hacks, tips and tricks, and all these things. Thank you again, and we'll discuss all your questions in the end of our webinar.
Very good, thank you, Alexei. All right, so hopefully you can all see my screen there. So just starting on the screen again, I think it's a great shot of the Matrice 300 with the SPH Engineering system on. You can see in the background here we have our system here. So being the Australian distributor for the system, we have a demo unit, so we obviously conduct demos around and also use the system to away from the other parts of the world at times, and is great for our customers. So I'll just tell you a little bit about our company. So GeoQ Australia is our central and initial business. So almost 3 years now in business, and as the name suggests, we're representing Australia for the GeoQ Group. So as you may know, GeoQ Group are American manufacturer of hardware and software. Quite a lot of background in drone-based and man-based hydrometry and LiDAR, and obviously the software component is quite an important part of that. So drone LiDAR and software, a little bit later. So the Geo Drone Solutions was basically started to look after all of the products and systems which the non-GeoQ systems. So a lot of the customers and people we're dealing with also have need for bathymetry-based products and other systems. So we've diversified and drones. We have the DJI drones, but also a number of other drones-inspired flights and different products to go with our TrueView sensors. With our bathymetry, we've got a number of different systems. We've been in the bathymetry field for quite a few years, and a lot of our survey customers do have needs for this as well. GPS and GNSS, we do have a relationship with CHC Navigation, so we supply their equipment. There's a lot of different software aspects which are also natural to supply with our various systems. So looking at our team, Paul Salmon is based here in Queensland. He's on the Gold Coast. He's our sales manager. Paul's a mining surveyor. He's got quite some experience with drones and LiDAR. Brad Redding's in Perth. Brad is sales and support, and Brad's a cadastral surveyor. Also has quite a lot of experience with drones and man-based flight as well. And Steve Lassen is here in Brisbane with myself. Steve has military background as well as quite a lot of drone-based background. Steve has a technical role. And we'll also shortly have Ben joining us in Brisbane as well, in a technical and an operational business. Just quickly looking at our LiDAR. So the GeoQ LiDAR has some fairly unique features, and as Daniel will talk to you a little bit later, has some relevance for the bathymetry-based use cases. So some of the unique aspects for the GeoQ LiDAR is the dual oblique cameras or the triple cameras now. So our RGB collection has the same width as our LiDAR collection, and LP360 software, which GeoQ produces and releases, is a one-stop software solution. So a few unique factors there. LP360 drone is the software that we're talking about, and LP360 geospatial is the modern office-based package used for manipulating point clouds gained from various sources, terrestrial or tripod-based scans. But LP360 drone is used for post-processing the LiDAR missions, and also a suite of tools in business intelligence tools for extracting data and post-processing. And as you can see here, the old one from DJI, the Zen Muse, benefits quite nicely from use of our LP360 drone software, and this one feature is quite well and is quite popular. Just looking at some of the areas that we work in, we work a lot with cadastral surveyors around the country. doing quite a bit with mining surveyors, mapping power lines, corridor mapping. We do a little bit with forestry, and more these days with emergency services and mitigation for things like flood damage. So, and obviously a lot of these areas, most of these areas have Bathy is quite a nice product that we have. So looking at our Bathy suite, we don't really do anything with manned Bathy, but our business is generally about drones and remote control. So we have a suite of products, obviously including the SPH Engineering drone-based system. With Bathy, we have a single beam dual frequency system here in Brisbane, so quite a nice, well-featured system. We also have the side scan based Bathy, which incorporates the Ping PSP side scan from Canada. So this is quite a nice system, giving you, as you can see by the image, scan data from below the water, which is essentially a cloud. So looking at our different options, we've got obviously if you can't get your boat into the water for various reasons, or if there's other reasons that the SPH system brings benefits, we've certainly got options there. Alexi spoke a little bit about green beam LiDAR. So we also have a green beam LiDAR system in our range. We represent the T-Dot system from Muse oneself in Japan. We supply one of these systems in Australia, which is really exciting. So this system, pretty much as Alexi said, has some fairly specific use case requirements in regard to clear water. 10 metres of water, generally speaking. This is a full cloud, so quite broad data collection underneath and above the water. And as you can perhaps tell, this one goes on an M300 drone as well, so it's quite light at 2.7 kilos. A little bit expensive, obviously, but depending on what you're doing, this can be quite a good option. And again, looking at our range there, lots of different options depending on your use case, and specifically about where the SPH product comes in. We also represent the CHC navigation GNSS systems in Australia, so the I-73 to the I-93 systems, quite small and compact and light, as you can see. These are all IMU-based systems. Internal battery, 18 hours of battery life, and the I-93, there's a nice camera system for bathymetry, so quite a nice range. Just getting a bit deeper into the SPH system. And as Alexi spoke about, once you've got the Sky Hub and the initial aspects of the system, moving towards other products, becomes quite a logical step. Obviously, the water tester is a nice one. And then whether it's a methane detector or GPR, there's lots of great options. So with the Bathy system, obviously we need a drone. At the moment, the Matrice 300 is the go-to drone, and we're working on the 350. Sky Hub central to the system, and the UGCS software is also central to the system, but also quite nice, and no doubt a lot of you are using this UGCS software. So UGCS Expert is the flight programming system, and we also use this software for LiDAR missions. Terrain following is a great feature. And we can also use Mapper as well. So as Daniel will talk about, an orthomosaic is somewhere we generally start the mission. So we need a fairly recent orthomosaic to have some accurate mission planning, and we can use it process that. Altimeter is quite important. So we're flying the drone RTK, but we also use the altimeter to get a fairly accurate Z. So we'll get more later on that. And obviously, it's a single frequency and dual frequency. At the mission plan, it's something you might be familiar with this type of screen. Mapper on the right and on the left. So as Alexa spoke about briefly, we can have a mission where we're dipping the sonar in the water. Often a good reason for using the SPH system is because of things in the water, whether it's weed or other issues in the water. Sometimes dragging the sonar might create some risk of getting it snagged. So in that situation, you're using grasshopper mode or dipping the sonar where you want is a bit of a safer option. And obviously, if we're dipping it, we're only getting patches of data where we're dipping, whereas if we can drag the sonar through the water, we're getting continuous lines of data, which is a better way to go. But if you've got those issues where you need to dip, that's certainly a unique feature. Also, when we're dragging the sonar through the water and putting some cross lines, we get those points where our lines cross each other, so we get two sets of Z data. So that's a nice achievement there. Gives us some confidence in regard to results. So with the altimeter, we have a laser altimeter or a radar. So we've just gone through the RCM process in Australia for the radar. That's a good thing to have under our belt. So, the laser or the radar, both situations where they will excel, and for above water, radar is the way to go. So moving forward, the radar is certainly the option to go with. Looking at the echo sounder, and generally speaking, for the bathymetry systems that we supply, we've generally always gone with the dual frequency. Single frequency is certainly available. It's a little bit less expensive, although the dual frequency has a few different benefits there for picking up tops of vegetations and the true bottom, or perhaps layers of sediment. The dual frequency does have this benefit. As you can see, both of these are weighted, so the aluminium housing adds some weight, and testing has certainly shown that this heavier weight or heavier pendulum offers some definite benefits for others. Just some general thoughts and considerations. So as I mentioned, we have the dragging, the sonar, or the dipping option for something like that. So with your area of interest, we definitely want to start with a recent ortho, getting an accurate water height. You have changes over time, and particularly near a river or something like that, the tree overhangs, playing a drone, definitely support that, so we can use that to do some application. Size of the job and what we can cover with each flight, depending on the line spacing that you want to employ, whether it's at an extreme of maybe 5 meters or perhaps 50 meters, depending on the application, and to space that out to get the results required. Flying nice and close together, we can have a short mission. And then also we can have an equal number of cross lines, and just maybe some random cross lines just as chairs. So just looking at a rough kind of size, if we've got an approximate water body size of 100 meters by 100 meters, 10 meter line spacing, that's something that we can achieve with one set of batteries. So with a little bit of buffer, we're looking generally 15 to 17 minutes of flight. Comments on that. I talked about cross lines, sets of batteries, obviously with the mission planning on and how big your water body is and how far the lines are going to be spaced. You can do some planning to that. So as I mentioned, we're flying RTK, so whether that's with a cause option or a base station, this helps position the drone with accuracy. Other things to think about, obviously, we're flying drones, so we need to think about the obvious NASA-based approvals and safety considerations, and permission and any other risks that we need to think about, instructions, obviously the wind as well, and whether we've got a current or whether our water body is tidal or whether it's still water. So there's a few different things to think about. Generally with bathymetry, but specifically when we're talking about the drone-based option. So the output out of the system is, as you can see, there's a lot of data coming out, depending on whether we're dipping or dragging the sonar. The sonar is always pinging, but when we're dipping, we'll only be getting those readings each time the sonar goes into the water. So, the dragging mission data. So this is the type of output. This is a CSV, so this will go straight into a variety of packages, although we certainly recommend to use Hydromagic. Hydromagic is, it's quite a widely used software package. It's quite economical compared to something like HiPack, for example. HiPack can certainly be used. Hydromagic is definitely the go-to option for, sort of cleaning up the data a little bit and producing depending on what you need. For those who want Hydromagic, a bit of familiarity. Okay, so that's it for me for the moment. So hopefully that was informative. I'll hand back over to Daniel and questions that have come through and make some steps to answer those after Daniel is finished.
Sure, thanks, Mark. So my name's Daniel Wood. I'm the owner and chief remote pilot of Working Drones Australia. We're a remote and rural terrain specialist in data acquisition across a broad variety of sensors, including a number of GeoQ products and SPH Engineering products. Our core services, I guess, are RGB, thermal, multi and hyperspectral, as well as obviously LiDAR and bathymetry that we're here to talk about today. What I wanted to do today is not really put up any slides or anything, but just take you through, I guess, what a standard mission looks like, including a recent mission that's on the smaller side, but really shows how the different technology working together can complement your business offering. So I assume from our audience we're talking to people who either have unmanned boats potentially, or they're using a stick-based method. Maybe they're not using bathymetry at all and are interested in getting into the market. So what I'll do is I'll share my screen. And excuse me, I do have a cold, so I may need to drink some water along the way. The first thing I'm going to show you as I share my screen is basically the perfect mission. So the perfect mission is one in a capital city that's frequently photographed from space, and you don't have to generate your orthos. You've got internet and everything's hunky-dory. And what we typically do for these perfect missions, and obviously you can see here, there's a great deal of access to this water basin, and it's a quality pond. Basically, it filters the water before it runs into the river. And so in a perfect mission, what we do is we would fly the edge of the area. We would also then do that, so we would do it in LiDAR to create a orthomosaic of the area, just so that we can import that and look to see if there's potentially any reed development which may snag or impair our echo sounder. We would then create a bathymetric path around the edge and capture the edge-based data. And then we start to look at things like outlining key structures. So for this customer, the key structure, which you can see is probably a little faint, so I'll zoom in a little bit, is this water quality catch fence. And so the catch fence is essentially trapping larger material. And so what we do then is basically put a nice little line around it, ensuring we're getting an accurate and well-spaced echo sounder to capture the sediment depth as well as the general water depth. Then, again, this is the perfect world. Then we go along and we fill it out by doing either dragging or grasshopper. So I guess the key difference between dragging and grasshoppering is obviously grasshopper is you can set it at specific distances to do a sounding, whereas dragging it, the echo sounder will remain in the water continuously. Typically, most of our customers aren't particularly interested, to be honest, in dragging the whole way. They are really interested in just getting an accurate view of the lake, sort of at a 10-metre spacing is pretty normal. One thing we do, and I did say I wasn't going to show you a PowerPoint slide, but I will show you just briefly for the purposes of this illustration. One thing that is of benefit when you're doing dragging, and this is all about understanding what it is the customer is trying to achieve. If edge definition is super important to the customer, then there are some certain benefits in dragging. And so in this example, you can see on dip 1, if you're doing grasshopper, and dip 2 and dip 3, if on the third dip you're too close to that dead zone, say you're within 20 to 50 centimetres of the bottom, you're unlikely to get a reading, or at least a good reading. So your only good reading is going to be on dip 2, which could be some 10 to 12 metres in this example away from the shoreline. Whereas if you were doing towed echo sounder, you could tow it right up to the shoreline and then it would cease operations or basically discard the data once you got into that dead zone. So you would have a better definition of where that shoreline is. So it's really important to understand what is the customer trying to achieve. So let me just open a new mission. And I'm going to take you on a little bit of a sort of day in the life per se. All right. So this mission looks significantly different. It's pretty messy. There's a few bits and pieces everywhere. And let me show you what that mission is and tell you just a little bit about it. So you can see this bridge in the image on the screen. This bridge recently was, the entire area was flooded, to be frank, and quite a bit of damage to the bridge as well as to this pond, I guess, immediately in front of the bridge. This river system is quite fast flowing, which you'll see in this video when I press play. And this bridge is used in a rural area for fire trucks and fire pumpers to basically park on, amongst other things, obviously bridge-related things like crossings. But they put a pump head into the water here in order to fill the tanker. Now, the pump head is worth many hundreds of thousands of dollars, so they don't want to drop it on a silty bottom, or they don't want to drop it on where there's a lot of debris. So this mission was twofold: get an understanding of the area and investigate the flood damage, as well as ensure that the fire service that used this area for remote and rural fire pumping services could continue to function safely. All right. So one of the first things we do on this job, and pretty much all jobs, is, as Mark alluded to, is get an ortho. Sorry, I've just got tools across my screen. Is get an ortho of the area. And the main way we do that is to fly, we certainly fly our LiDAR unit, which is a 535, and we get a nice ortho of the area as well as LiDAR data. So you can see here, I mean, this is just one up and back pass, and we're able to gather pretty much all the data we need. And the key reason that we get ortho in this way is really enriched by the benefits of the UGCS software. And the primary software we use once we've got the ortho is UGCS Mapper. Now, I won't do it, but UGCS Mapper is super easy to use. You're really just pointing it at your collected images and then selecting an output directory and then processing it. Now, you might say, well, why do we need an ortho? It looks pretty good here. Well, let me show you. Again, I've got controls over my important layers. Let me just show you what the actual river looks like. So this is the Google image in UGCS Expert. And then when we lay the actual, you can see that sandbar that was there and the trees in general have moved somewhat. So I'll take it off and then I'll add it back. So when we're planning the mission, obviously we do it in areas that are important to us, and we don't want to put quite an expensive echo sounder directly into a sandbar. So the first thing we do is we get a nice ortho, and using something like the 535 with the 3 cameras allows us to get that in. And again, the UGCS Mapper, when you're doing these bathymetry jobs, you're quite often in a valley. The rivers don't flow over mountains. You're typically in the middle of nowhere. in a valley with no internet, no ability to process in any meaningful way. So having the tools and capabilities of the UGCS mapper, as well as obviously the offline maps capability in UGCS Expert, really allows us to be successful in that type of terrain. Excuse me. So I'll just play this video again. So it might be a little bit difficult to see, but in the center of the video, you can see the M300 with the echo sounder. This is quite a turbulent river, as well as it's quite fast flowing. It's not the most ideal circumstances to do this, but the focus, again, has to really be on what is it the customer is trying to achieve. So in this case, the customer needed 50 centimetres of clearance. So when we're looking at water depths of 1 to 2 metres, the inaccuracy from the tilt in fast-flowing currents is relatively negligible. You're talking, once you go beyond 15 degrees, it's only a few centimetres. Obviously, if your customer is after survey-grade accuracy, then that's a different sort of challenge to solve. There are ways to improve it, and when we talk about accuracy, we're really talking about the tilt of the echo sounder as it's pushed against by the current. So one way, and I don't know if this is the SPH Engineering endorsed way, one way I've found to deal with that is to actually sink the echo sounder deeper and then leave it for longer, so say 5 seconds, and then come out. And that sort of action of ascending tends to pull the echo sounder straighter, and you can get some really good results. Okay, so once we've done our ortho map, here we were basically creating a mission and capturing some points in grasshopper mode to really understand, well, what does this water look like? And you can see, again, contrasting to that first one, there's a lot of mess here. So you can see I've added these 2 flights, and when you're out operating in this type of terrain, you quite often will do a basic line where you know is safe, and that's really represented by this zigzag pattern down the middle. And then you may choose to fill in areas where you've flown the safe line and you realise, well, there's actually a little bit extra data I can collect on the side. And so it's not this nice, perfect world view that we saw in that first mission planning. You can add additional data to the sides. So one of the things that's good about doing the LiDAR flights as well is our ability to classify the ground. Now, this presentation is all about bathymetry, but the beauty of classifying the ground is being able to see underneath the trees for where the actual riverbank is, because it's important when you're doing your, modelling inside of Hydromagic to understand, from an ortho point of view, you may think, I might just turn on the ortho. So if we have a look on this left side, you might think that this tree, for example, is ground, when in fact, you can see on the right-hand side that the bank extends quite significantly under that tree. There's a lot more water there. So one of the things we do as far as LiDAR goes is we capture the bank, and let me just show you what that looks like. So it might be a little hard to see. Let me just force it. So there's not a lot to see here, but you're basically seeing an outline of the bank, and we import that into Hydromagic to allow us to cleanly define the edges, and I'll show you that now. So what you've got on the screen is Hydromagic, and you may be able to see, it's a little bit difficult to see the actual black numbers here, but that's sort of not really the point of what we're talking about at the moment. This view you can see is the Google Earth view of this area, and if I turn on our actual view, you can see that it does shift quite a lot. Now, back to the point of why we're flying LiDAR. So with that edge that was outlined, you can import the LiDAR data, and it looks very, very messy and very noisy, but you can use this to then draw the boundary of the intense areas. And you can certainly filter this more. I just sort of started at the point level. So you're ignoring the lines, but you're basically drawing a boundary around the areas that you know are water or ground in this example. You can see that here. And what that allows us to do is, already got it open, is to take those measurements and turn it into a 3D model. So you can see here, this is a filled-in 3D model, but we can go to wireframe and indeed to point cloud. And I guess the message that I really wanted to get across is that you need to really focus on the customer's requirements. This customer in particular was interested in 50 centimetres of water. We were able to quickly fly LiDAR, grab the ortho photos, process it in UGCS, plan our missions in UGCS Expert, execute them, get the right data rapidly in a very remote area, and they had a fantastic outcome. That's pretty much what I wanted to show you. I guess to sort of leave you with a little bit, again, understand what your customer needs from their data. A lot of us spend a lot of time collecting data that the customers are just not interested in. And as far as drone-based Bathy goes, that takes a lot of time. So if they're not interested in edge definition, don't fly right up to the edges. If they're not interested in, 10 points per second, don't drag your echo sounder. The second part, I guess, is depending on the audience that I'm talking to, and potentially you might be looking to break into bathymetry. There's a lot of other technology, like you saw LiDAR, you saw ortho. If you're looking to get into bathymetry, potentially try and offer your services to teams that already do it. They may be unmanned boat-based, like the McBathy, or indeed actually boat-based. And I'm sure you can enrich their data with some of the product and technology that you've seen today. So I hope that was helpful. That's all I've got. Thank you.
Hey, Daniel, thank you very much, mate. That was, definitely was interesting and certainly helpful. Can I just ask you a couple of questions? So we've got a few questions come in and a number of them relate to some aspects of your presentation. So we know that you had a camera on the drone, a GoPro perhaps. Was that just for this purpose, or do you put that on there, occasionally for other means?
I do it a lot for testing. So depending on what I'm testing, I'll often have a GoPro attached to the M300. I do know there's a question here from Robert Dulesky, and I'm not sure if that's the correct pronunciation, Robert, but hopefully it is. With the SkyHub system and the bathymetry system, it doesn't obstruct the skyport. So you're able to attach to the skyport. The laser altimeter is kind of present in that location as well, but if you have a small camera like an XT30 or something, you're able to also use the skyport for that purpose. How do you know the sensor is working? So alongside the UGCS Expert software, there's also a payload monitoring or a custom payload monitoring software that gives you real-time telemetry, and it gives you not only the altimeter from the laser, or if you're using radar, indeed to look at the radar, but it also gives you the echo sound depths as well. So that's really helpful. And I can see there's a couple of questions about current and I guess the current speed. So the current speed you saw there, I think I measured it at 9 knots. Now, it's not ideal. Let's be honest. It's not ideal for an echo sounder to be at that tilt. But some of the tools that the SkyHub gives us is the ability to filter out data that's junk at the inception, rather than trying to deal with it post-process. So we typically filter out data beyond 15 degrees. Obviously, if you're talking about 100-meter depth sort of river, that's going to be a real big problem, because it exacerbates the distance. But if you're talking 1 or 2 meters, it's not such a big deal. You're only talking about centimeters in that case. Like I said, there's a few tips and tricks to try and get that tilt down. One of which is to accelerate upwards, so potentially take it lower to the river and accelerate upwards, which tends to bring the weighted echo sounder more in line with what you're after. Noah Coleman asked, are the automated missions designed to dip without operator assistance? Yes. Yep. So in the custom payload monitor, you're selecting your depth as well as your wait time, so how long you want to stay there. And you can set the spacing and obviously all the different mission areas. And that occurs without the operator doing anything. Obviously, as a drone operator, you need to be monitoring pretty much everything. The payload, the altimeter, obviously, the wind conditions, they all sort of have an impact on the quality of the data. Nick asked, how long would a small ortho production take to produce so you can use it while out in the field? Oh, no, it's minutes, Nick. So that ortho, I think I had 120 photos. And I must admit I have a pretty good laptop, but it was done sort of 3 to 5 minutes tops for the area you saw. Obviously, if you're flying, something substantial like the broader parts of the Murrumbidgee or Murray River in Australia, that may take a little bit longer. So Anthony Boyd has asked, from your example, what were the accuracies the client in this case was after? So look, that's a really good question. In this example, what they're really trying to say is, do we have 50 centimetres of water or greater so that we can float our pump head without damaging multiple hundreds of thousands of dollars worth of equipment? As far as, that's probably not really your question, as far as accuracy that we can reliably produce, I would say it's accurate to sort of 3 centimetres at 5 to 10 metres. And then you tend to lose from testing, I don't know if SPH has a better answer than this, but from testing you tend to lose about 5% every 10 metres beyond that. But I think that's really in line with other Bathy products, to be honest. I don't know, Alexi, if you've got a better answer than that.
You're right. And the longer legs, right, of fly paths you have, the more it increases the accuracy. So you can plan your mission in the way that to exceed, for instance, 10 or 20 meters legs. Yeah, so you can split your mission in several, and this will help you to maintain required accuracy.
Yeah.
Might be able to answer the first question, gents, from Casper about using the system of underwater bathymetry for shallow and structurally complex reefs. 0.5 meter, 20 meters of depth.
I would say it depends on what you want to achieve. If you want just to understand what is the profile of this coral reef, then bathymetry may work and will work, and it will be faster and probably cheaper. But if you want to understand the structure of these reefs, then I would go with green lidar. What do you think?
Side scan, potentially.
Side scan in a manned boat or a remote control boat.
Or a boat. Yeah, you're right.
So looking at your cost points, if you're 450 grand for green beam drone lidar, or maybe 250,000 for a side scan remote control boat. Particularly if you're talking about 20 meters of water, your depth there is not a problem, and you get great visibility of the vertical structures there as provided there's enough water over the top of it. Great detail over the top as well. There's a few questions about sharing this afterwards, and in a couple of days that will be on the SPH YouTube site.
Yep, please check it. And there are a lot of great videos.
Question there, Alexi, about heavier drones. Did you want to address that one?
It's a question from Chris Nielsen. In general, any PX4 based heavy lift drone should work, but you'll need like some preliminary testing. We have tested this drone-based T1000 heavy lift drone with our solutions, and it works. So if you need to, I don't know, to collect like 5 liters of water samples, then yeah, this drone can work.
Yeah, and Paul asked a question with regards to fixed wing LiDAR for bathymetry. So my response to that is quite similar to most LiDAR. So the faster you fly, the less density you get. So if your goal is to get a high density model, like a previous question was asked around reef structures, then fixed wing LiDAR is just too fast for that sort of resolution. It's really good for understanding sort of broad coastal, but certainly if you need to get any real resolution, you need to go to your boat-based, etc. I do think there is a place for pretty much all the solutions working together. For example, things like the Bathy, brilliant for around structures like, you know, docks, around areas that are challenging to fly drones. They're good in open water to a degree, but you wouldn't take them 5 miles offshore. I mean, maybe Mark would. Boats, similarly, quite expensive, but they're difficult. They can't get under docks. Obviously, drones can't get under docks either. But you can typically have bigger systems. And when you've got more space, your systems, they can actually come down in price as well, because you're not having to design these compact, lightweight systems for drones. But quite often you can work together. There's been projects where there's been boats in rivers, and the drone has been able to do river sort of rivers that come into that primary river that might be obstructed with vegetation, etc., or rocks, and allow us to complete data collection in areas that were just impossible previously.
Good, thank you, Daniel. I think that's all of our questions wrapped up. So, I think we might finish. So, thank you very much, Alexi and Daniel and the SPH team for helping with the webinar and facilitating, and of course to our guests, thank you very much for attending and for your interest. It's terrific to see. And I think as we've probably summed up, you know, there's some fairly obvious reasons for going with the SPH drone-based system. You know, if you've got difficulty getting into or out of water, if the water is remote, there may be situations where you're not allowed to approach the water due to the type of the water. Surf is an obvious application. In rivers where you might have to do lots of cross sections, it's a great option rather than putting a boat in and out of the water on multiple occasions. So there's heaps of reasons for using the system, and hopefully we've answered your questions around that. But certainly, if there's any other questions, or if you'd like to see a demo or see some more data, please feel free to reach out to us. Our number is 1300 900 303, and if you'd like to send an email, that will just be to info@geodronesolutions.com.au. So with that, we'll wrap up. And again, thanks very much to Alexi and Daniel and the SPH team, and of course to our guests. Thank you very much. It's been great, and we'll talk to you again soon. Have a good day.
Thank you so much. Have a great day.
Thank you. Bye.